One, two. Good evening. This is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast coming to you from the studios of VK3CSJ in Narre Warren South on this third day of October 2025. And we're broadcasting on the prime frequency of 3541 kilohertz in the 80 metre amateur radio band, and streaming on my Discord channel and on my YouTube channel, VK3CSJ. Just look for the live indicator. Yes, okay. We weren't here last Friday due to the Melbourne Cup Melbourne Cup, that's still coming up, due to the AFL footy business, and because it was a public holiday. So anyway, I decided to take the day off. So there it is. We're back here again right now, and we've very quickly and hastily put some articles together. And because it is the first day of the month, with the first week anyway, at least. Of course, we've got the usual sky notes brought in the email from the planetarium from Dr. Tanya Hill, the resident astronomer at the Science Works Planetarium, and we'll work our way through that in just a moment. But in the meantime, we'll run through the usual blurb for the ASV, and you can find this information that I'm about to read on the ASV website under the About Us tab. ASV is a non-profit society for people interested in astronomy, attracting and catering for people from a wide range of ages and backgrounds, abilities and interests. First formed in 1922, the Society has grown to over 1,000 members. Its activities are coordinated by a council of elected office bearers, section directors and ordinary councillors. The ASV has weekly activities at our two metropolitan locations, the Morley Community Village and the Melbourne Observatory. And we host monthly Astro Talks at the Herbarium near the Melbourne Observatory. The Society's library is also located at the Melbourne Observatory and is open during Astro Talks. For over 50 years, the ASV has played a major role in the care of buildings and facilities at the Melbourne Observatory. Our members conduct astronomy for people gatherings throughout the year, bringing telescopes and astronomy to Melbourne's parks and schools. Just check the online calendar on the ASV website for details if you are interested in attending any of these particular events. The ASV is currently involved in a number of major projects. We are involved in the restoration of the Great Melbourne Telescope and are also currently working on the installation of a series of remote telescopes and at our dark sky site, which once completed will be accessible to our members for their use. In fact, I think a lot of that is now being prepared, and I know that there is now a video of instruction that has been produced and released for members to look up and understand how to access these remote telescopes and how to use them. And it's like a little course thing that you have to go through to make sure that you understand how to access those telescopes. Thanks to a generous donation from one of its most long-standing and respected members, the Leon Mao Dark Sky site located north of Melbourne has a pristine night sky for deep sky observing. The ASV has a 25-inch telescope, a 40-inch telescope and a wheelchair-accessible 16-inch telescope on the site up there. And there's also a fully steerable 8.5-metre radio telescope which can be accessed through involvement with the radio astronomy section. An annual yearbook is supplied to members, as well as a bi-monthly newsletter called Crux, which all members are welcome to contribute to. The ASV's logo sports the Southern Cross and pointer stars. It has a Latin motto, which once translated is "This way to the stars." The ASV is governed by a set of rules which should be read before applying for membership. There's a link to that just below that statement under the About Us tab. Any person or organisation with an interest in astronomy may apply for membership of the Society. And that's about all that there is there. So the ASV website is available at www.asv.org.au www.asv.org.au. Forgot to mention we're also broadcasting via the Melbourne television repeater VK3RTV digital channel 1, which is, I haven't checked, but I would imagine it is also broadcasting on the British Amateur Television Club's video streaming service. So if you can't see the TV repeater, there should be a link, automatic link created from the repeater site to the BATC video streaming service. So I just go to the BATC website, I look for the video streamer and look for repeaters that are on air, and you'll see RTV1 and RTV2. Just click on RTV1 to be able to see the output of the TV repeater. Otherwise, the repeater can be viewed directly if you're in the metropolitan area on 445.5 megahertz DVB-T2 HD. It's 100 watts, just over 100 watts of DVB-T2, and it's vertical polarized transmission. Alrighty then. You're tuned to ASV Radio VK3EKH. I hope all the audio levels are okay. Since I haven't used this for a week, audio level on vMix tells me it's just into the red as I speak, so that should be okay for YouTube. I might just knock it down a tad. There it is. That's a tad. 1, 2, 3, 4. So that might be all right. Alrighty then. Now, next online. Everything seems to be there. We do have an email address if you wish to send signal reports, vk3ekh@gmail.com, vk3ekh@gmail.com for any signal reports as such, which I think I am monitoring. Yes, I am. Okay, so there it is there. Sky notes for October, courtesy of Tanya Hill at the planetarium. In fact, my niece and a teacher friend of hers, they went to a presentation by Tanya Hill at the planetarium last Thursday, and it was a very interesting couple of hours at the planetarium. They learnt a lot of things, but I had a phone call, I think about 9 o'clock, from my niece, Tiffany, who said, look, we're about an hour away, but I'm bringing my friend with me, and she's real keen to see your scope dome, the observatory at the back. And I thought, yeah, okay. There's no telescope set up yet, but I can at least articulate that there is one there. So anyway, an hour later, they came up the driveway, and I introduced them to the dome. I had it all lit up so they could see how it looked, and introduced them to the concept of what it's all about. And they were most impressed. So Tiffany tells me that one of the points of discussion at this at the planetarium last Thursday was about the comet Atlas 3, I think it is, that's in the skies at the moment. And apparently October 20 is around about the best time here in Melbourne to see this. I don't know how well you'll see it. I'm not too sure about that, but certainly if I can get a telescope set up, hopefully, maybe, by then, we may be able to actually view this thing through the telescope, which would be quite interesting. Anyway, we'll see about that, because I don't move very quickly. I'm very slow to move on anything I do these days. Anyway, that's another story. So, yes, Tanya Hill's Sky Note starts off, actually, with a century of planetariums. And I'm going to go into that as soon as I finish with the rest of the Sky Notes. It's a different article altogether, because she says here that it's been a remarkable journey from 1925 to 2025, bringing the stars indoors for all to enjoy. Learn the story of technical innovation and creativity in this article from the conversation. For 100 years we have marvelled at planetariums, and that's a link. So I've clicked on that link, and that's opened up another page altogether. So I've got that queued up, and I'll work my way through that in just a moment. We'll see how we go. Yes, okay. Oh yeah, now she supplies a picture here of a planetarium. I'll just bring that up on the screen here. There it is. And what she says about that is that okay, interior of Melbourne's first night sky theatre, the H.V. Mackay Planetarium, or Mackay, the H.V. Mackay Planetarium, located on Swanston Street in the heart of Melbourne, in the then Science Museum, formerly the Institute of Applied Science. Who remembers that? I thought that was an amazing place to visit as a kid. Particularly the old Science Museum. I just used to wander in and look at all the things that they have set up. And I remember visiting the planetarium a number of times with this dome that had no end to it. It was lit in such a way that there was a uniformity of light reflecting off it, and you could never see, you couldn't perceive the ceiling. It was just this lovely glow. But when the lights lowered and the projector turned on, just mind-blowing experience. So yes, a building now fully occupied by the State Library, a popular attraction for the public and schools. The planetarium operated from 1965 until 1997. This 1970s photo that you see at the moment shows a circular seating for around 110. the central Japanese go-to M1 optical star projector and the 10-metre fiberglass double. There it is. It was a 10-metre high fiberglass dome. 10 metres. Fiberglass dome from Mock City Skyline. Seasonal and especially themed shows were all live and included images from mechanical slide projectors and special effects projectors, sound effects, music, and commentary by the presenter. So I remember all that. I didn't know that it was a Japanese go-to M1, but you could have fooled me. But that was amazing. So that's that projector, and I vaguely remember seeing that. I vaguely remember that big black thing. I was more intrigued in what was reflecting off the or being projected onto the screen. Anyway, December. Tanya says here that the December Sky Notes will feature more about Melbourne's first planetarium as we mark the 60th anniversary of its opening in December 1965. Well, there you go. All right, Melbourne Sun Times. If you're interested in the sunrise and sunset, this weekend is the daylight saving thing. So this particular Sunday, we're winding the clock 1 hour forward on Sunday. So daylight saving kicks in on Sunday, whether you love it or don't. Anyway, on Wednesday, the 1st of October, sunrise was at 5:55 a.m., setting at 6:24 p.m., with the day length being about 12 hours and 28 minutes. However, on Saturday, the 11th of October, sunrise will then now be at 6:40 a.m., setting at 7:33 p.m. There it is, our evening light has returned. The day length is 12 hours and 52 minutes. Come Monday, the 21st of October, sunrise will be at 6:26 a.m., setting at 7:43, with the day length being 13 hours 16 minutes. And by the end of the month, Friday the 31st, sunrise will be at 6:14 a.m., setting at 7:53 p.m., almost 8 o'clock, with the day length being 13 hours and 39 minutes. And she does actually say here that the Australian Eastern Daylight Time begins on Sunday the 5th at 2 a.m. when we move the clocks forward 1 hour. There will be a full moon on Monday the 7th, a third quarter phase on Tuesday the 14th, a new moon on Tuesday the 21st, and a first quarter phase on Thursday the 30th of this month. Lunar apogee, furthest from the Earth, is on Friday the 24th at 406,444 kilometres, and the lunar perigee, closest to the Earth, is on Tuesday the 8th at 359,819 kilometres. The planets. Mercury, after its solar conjunction, is now visible again in the west from 8 p.m. before setting around 9 p.m. Venus has drawn too close to the Sun this month for observers in Melbourne. Mars is about to have its solar conjunction and pass behind the Sun, but can still be seen this month low in the west at twilight from around 8:15 p.m. before setting by 9:30 p.m. Jupiter is now visible again from 3 a.m. in the east before fading in the dawn light by 6:30 a.m. Saturn can now be seen again in the east at dusk from 8 p.m, after which it will move across the northern sky before setting in the west by 5 a.m. Meteors. The Ionids appear from the 15th to the 29th, but peak on the 21st and 22nd, with perhaps 30 meteors per hour from midnight until dawn. Centered on Orion, near the red supergiant star Betelgeuse, they are typically very fast and bright, entering the atmosphere at 66 kilometers per second and vaporizing 100 kilometers above the surface, leaving persistent trails. Dr. Tanya Hill and Professor John T. Horner explain the meteor shower in The Conversation. There's a link they provide there. And there is a picture here too. This is explaining where the radiant of these meteors will come from. So if you're up in the morning, particularly when it's at its peak on the 21st and 22nd, that's you're looking towards the northeast at the constellation Orion, and that's generally the radiant from where these meteors will be coming from. That's if you've got the program Stellarium. It's a free download. Stellarium. This is what you're seeing on the screen. There is a view of for 1 a.m. The three bright stars of Orion's belt, or the base of the saucepan, and the red star Betelgeuse below will guide you to the Ionids shower. The Ionids shower was first recorded by the Chinese in 288 AD and is associated with Comet Halley. In 1705, Edmund Halley, after studying records of comets that seemed to reoccur and using Isaac Newton's new laws of motion, calculated the comet's orbit and predicted its return in 1758, something he did not live to see. Every 75 years, Comet Halley passes through the inner solar system, leaving a trail of particles for Earth to pass through twice a year, the April-May Eta Acarids and the October Ionids. Right. Stars and constellations. In the north, if we face northwards, visible this season are the Aquila, the Eagle, and its principal star Alta, directly north. If we turn to the west, Scorpius is now moving down to the west with a red giant star Antares, the middle of these three stars that mark the Scorpion's body. High above, following the Scorpion, is the asteroom the Teapot, which gives you the position of the bow and arrow held by the Centaur Sagittarius. The centre of our Milky Way galaxy lies in that direction, some 26,000 light years away. If we turn to the east, Fomalhaut in Pisces, Southern Fish, is the bright evening star in the east this month. But as spring ends and we move towards summer, we will progressively begin to see from the northeast to the southeast a rich collection of night sky objects, such as the beautiful Pleiades cluster, the Seven Sisters, Taurus the Bull with the red star, giant star, the inverted Orion, the Hunter, the right way up saucepan in its centre, and a red supergiant, and also Canis Major, the brightest nighttime star Sirius, also known as the Dog Star. In the south, in a dark sky, in the southeast are the isolated large and small clouds of Magellan, our galaxy's nearest neighbours, as well as the vast band of billions of stars and dark dust clouds that make up what we can see of our own galaxy, the Milky Way. In the evenings this month, it runs in a broad arc from south to north. From our location in our disc-shaped galaxy, we have an edge-on view along the plane of the galaxy where the density of the stars is greatest. As you look away from the Milky Way to either side of the sky, you see far fewer stars, because in those directions you are looking through only a few thousand light years out to the intergalactic space, to the north or to the south of the galactic plane. Low in the southwest are the pointers Alpha and Beta Centauri in the constellation of Centaurus, the other Centaur in our night sky. Following the line of the two bright pointers leads to the Southern Cross. The International Space Station. Oh dear. At a distance of about 400 kilometres, the International Space Station completes an orbit every 90 minutes and appears as a bright point slowly moving across the night sky. Here are some of the brightest passes expected this month over Melbourne. On Saturday the 4th, there's a passing at 5:17 a.m. to 5:23 a.m. southwest to the east-northeast corner. On Tuesday the 7th of October, there's a passing at 5:27 a.m. to 5:32 a.m. southwest to the northeast. During the evening of Saturday the 11th, there's a passing that starts at 8:25 p.m. to 8:32 p.m. northwest to southeast. And on Tuesday the 28th, there's a passing at 8:52 p.m. to 8:57 p.m. coming in from the southwest to the northeast. That's considered the brightest passes, but there's multiple other passes that the International Space Station does do over Victoria and Australia in general, but at different variety of angles in the sky. The Heavens Above website gives you predictions for visible passes of the space stations and major satellites, sky view, live sky views, and 3D visualizations. Be sure to first enter your location under the configuration tab on the Heavens Above website. But the Heavens Above website's been around for a long time and is a very valuable resource for knowing what's up in the sky, whether it be celestial objects or satellites, a variety of satellites. It's all there. It's a great little website, heavensabove.com. Let me just switch back to live camera. Where am I? No, we'll go to that one. Just checking email. On this day, what is the day today? It's the 3rd, that's right. On this day, there's a few dates here supplied by Tanya. I'll go through some, not all of them. On the 3rd of October, 1942, first object to reach space, the experimental V2 Vengeance rocket was launched from the Peenemünde, Germany, in a brief flight from the Baltic. On the 4th of October 1957, Sputnik was launched to become the first artificial satellite. Also on the 4th of October 2004, Spaceship One was launched as the first private spacecraft into space. On the 5th of October 1923, Edwin Hubble established that M31, the Andromeda Galaxy, is separate to our own Milky Way galaxy. On the 7th of October 1959, first photos of the Moon's far side are taken by Luna 3. On the 9th of October 1604, a Type 1a supernova some 20,000 light years away in the constellation of Orpheus is visible from Earth. And on the 17th, Johannes Kepler observes and publishes his account of the new star. It is the most recent supernova visible to the naked eye in our galaxy. On the 10th of October 1967, United Nations Outer Space Treaty on the peaceful exploration and use of space was established. By now, 109 nations are signatories and several other agreements and conventions have been created to cover space law. On the 11th of October 1958, Pioneer 1, a battery-powered probe aiming for lunar orbit, fails to reach escape velocity and burns up. Also on the 11th of October 1968, the first crewed Apollo mission, Apollo 7, launched into Earth orbit in a test of Saturn V rocket and Command and Service Module CSM. On the 12th of October 1964, USSR's Voskhod 1, or Sunrise, was the first spacecraft with a crew of more than one, in this case 3 cosmonauts who orbited for 41 hours. On the 13th of October 1773, the Whirlpool Galaxy M51, 31 million light-years away in the constellation of Canis Venetia, is discovered by astronomer Charles Messier. On the 18th of October 1967, Vienna 4 is the first probe to analyse the atmosphere of another planet when it does so at Venus. And on October 19, 1910, this is a hard name to pronounce. Yes, take my word for it, it's going to be tricky. But on the 19th of October 1910 was the birth of Subramanian Chandrasekhar. I think he must have been Indian. Subramanian Chandrasekhar, who had major insights into stellar evolution and black holes. Subramanian Chandrasekhar, something like that. One more date. On the 24th of October 1998, Deep Space One probe was launched to test innovative technologies, including an ion engine, while visiting asteroid Borrelly and comet Borrelly. All right. There's actually 2 more dates. That's all there is. So, all right, I'll continue on. On the 27th of October 1994, first substellar object orbiting a star is found, a brown dwarf, at Gliese 229. On the 29th of October 1991, Galileo Probe USA is the first to visit an asteroid, Gaspra 951, on its way to Jupiter. And finally, on the 31st of October in the year 2000, Expedition 1, first resident crew of the International Space Station, arrived by a Russian Soyuz craft for a 136-day stay lasting until March 2001. The 3-person crew, 1 American and 2 Russians, made the station fully operational, hosted 3 visiting US space shuttles, and received 2 Russian Progress supply vehicles. Those were the days. Thanks, Tanya Hill, for the Sky Notes for this month. And we'll now go and visit this article on the planetarium. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast. Yep, that's high. All right. So, let's see about this planetarium. A century of planetariums. There it is. No? Where is the article got to? I know it's around here somewhere. I did open up a page. Maybe I've inadvertently closed it. Looking at all these pages I've got to open. I must have closed the page. Well, I've got 2 pages of Sky Notes open. That's what's happened. For some reason I've done that, which means that one there is the planetarium article. So I shall open it. The Conversation is a website dedicated for interesting conversations. All right, for 100 years we have marveled at planetariums. Here is a brief history of how humans brought the stars indoors. Picture this: a small audience is quietly ushered into a darkened room. They gasp in awe as a brilliant night sky shines above. They wonder, as many after them will do, what trickery has made the roof above their heads disappear. But this is a performance. The stars above, an ingenious projection. For the first time, the public audience has experienced the spectacle of the optomechanical planetarium. The location is the newly opened Deutsches Museum in Munich, built to celebrate science and technology. The date is May 7, 1925. Visualizing the heavens. Throughout time, cultures around the world have used the stars to help make sense of the world, to understand where we come from, and to determine our place in the cosmos. People have tried to recreate the movements of the stars and planets since antiquity. In the 1700s, the orrery, a clockwork model of the solar system, was developed. The word planetarium was invented to describe orreries that featured the planets. One room-sized orrery example was built by the self-taught Frisian astronomer Isa Eschinger. I'm not sure how you pronounce that, but it'll do. It's still operational today in Frankfurt, Netherlands. Frankfurt. No human has ever been to the edge of the solar system to see this view of orreries and other mechanical models of the universe like celestial globes present views from impossible external perspectives. The first planetariums. The desire for a realistic view of the stars and planets created from our perspective we actually see gathered pace in the early 20th century as light pollution from growing cities diminished the view of the night sky. People like Oskar von Miller, first director of the Deutsches Museum in Munich, Germany, wanted to return this vision of the stars and planets to everyone. Ironically, von Miller's earlier career was an electrical engineer rolling out the city lighting, and with that contributed to the light pollution. One early attempt to create this view of the night sky was at the Atwood Sphere, installed at the Chicago in Chicago in 1913. Approximately 5 meters across, it was made of sheet metal perforated with a star map. When viewed from inside, the light shining through the 692 pinholes replicated the Chicago night sky. The whole structure could even be rotated to simulate the motion of the stars. A realistic display of the stars is one thing. Representing the planets whose positions in the sky change from night to night is a different one. Von Miller and others at the Deutsches Museum knew that fixed holes could not represent the complexity of a moving planet. What if the planets were displayed by projection? If so, couldn't the stars be projected as well? With this realization, a new kind of planetarium was born, borrowing the name from early orreries, but working in a completely different way. The task of building such a device was given to the German optical company Carl Zeiss AG. After many setbacks, their first planetarium projector was completed in 1923, with the first performance at the Deutsches Museum about a century ago today. Planetariums were a hit with the public. Within decades, they had spread around the world. The first planetarium in the United States opened in Chicago in 1930, while the first one in Asia opened in Osaka, Japan in 1937. The popularity of planetariums particularly, there's a group of words for you. The popularity of planetariums particularly accelerated in the US during the space race in the 1960s. Australia's oldest operating planetarium is the Melbourne Planetarium, managed by the museum's Victoria since 1965. In Otatora, New Zealand, Auckland's Star Dome Observatory has been in operation since 1997. The current longest running planetarium in the Southern Hemisphere is in Montevideo, Uruguay, operational since 1955. Changing pace of technology, the optomechanical planetarium projector remains a technological wonder of the modern world. Individual plates perforated with pinholes are illuminated by a bright central light. Separate lenses focus each projection from one of the star maps to fill the entire dome with about 5,000 stars. The Sun, Moon and planets have separate projectors driven by gears and rods that mechanically calculate the object's position in the sky for any time or place. By the 1990s, a digital revolution had begun. With the advent of computers, the position of the planets could now be calculated digitally. The Melbourne Planetarium became the first digital planetarium in the Southern Hemisphere when it was installed the DigiStar 2 in 1999. The system, developed by computer graphics company Evans and Sutherland, replaced the multiple lenses and early projectors with fisheye lenses. A single beam of light swept across the whole dome so rapidly that it seemed to create a single image, albeit in a bizarre green colour, rendering a star field of fuzzy green blobs. The trade-off for a less crisp star field was a 3D database that, with more than 9,000 stars. For the first time, planetarium audiences could fly through space, far beyond the edge of the solar system. Planetarium technology continues to develop. Today, most planetariums operate through video projection, known as full dome. The output from multiple projectors is blended together to create a seamless video, transforming the planetarium into a sophisticated 360-degree theatre. Astronomy has also changed over the last century. Just as Zeiss was completing its first projector, Astronomer, Edwin Hubble discovered that other galaxies exist beyond our Milky Way galaxy. The stars shown on the dome in Munich in 1925 turned out to be just a tiny part of the universe that we know today. Planetarium's digital systems now incorporate data from telescopes and space agencies around the world. Audiences can fly off Earth, orbit the planets and the moons of the solar system, and explore billions of known galaxies. Yet some things have not changed. From orreries and lantern slides to optomechanical and digital planetariums, the communication of astronomy has always been about more than just the latest results of science. The power of the planetarium over the last 100 years has been its ability to evoke and wonder awe. It taps into the enduring fascination with the vast mystery of the night sky. You're tuned to ASV Radio, VK3 Echo Kilo Hotel. There's a little bit of a history there on planetariums, which I thought was interesting. And we'll follow up that with the write-up that Tanya will do on the Melbourne Planetarium, more of the Melbourne Planetarium in the December edition of Sky Notes. Right. It's just a little bit of history. Here's a picture of a young lass. Where are you? There you are. And who you are looking at there on our image TV device. October 1, 1847. Miss Mitchell's Comet. Today in the history of astronomy, Maria Mitchell becomes the first American to discover a comet. 1st of October they're referring to, 1st of October 1847. Maria Mitchell spotted the comet that would make her famous through her family's 2-inch reflecting telescope. 2-inch. On October 1, 1847, Maria Mitchell was positioned on the roof of the Pacific National Bank on Main Street in her hometown of Nantucket, Massachusetts, sweeping the sky with her family's 2-inch reflector, where she spotted a small object that did not appear on any of her charts. Though not able to be seen with the naked eye, the object was visible, if blurry, through the telescope. Mitchell told her family, also an amateur astronomer who was eager to announce her find. Mitchell was cautious, though, however, continuing to observe and verify her conclusions that the object was a comet. On October 3, her father sent notice of her discovery to the Cambridge University. The comet C/1847 T1, or Miss Mitchell's Comet, brought Mitchell recognition in America and abroad, including a gold medal awarded by King Christian of Denmark. Mitchell would go on to become the first professor of astronomy at the Vassar College, and the first female member of the American Association for the Advancement of Science, AAAS. The telescope with which she discovered the comet is now displayed in her childhood home in Nantucket, just down the street from the headquarters of the Maria Mitchell Association, which continues to provide and support science education as part of Mitchell's legacy. There you go. Just that simple little discovery using a fairly modest telescope, and that leads to her whole life changing. It's amazing stuff. You're tuned to ASV Radio, VK3EKH, the official station of the Astronomical Society of Victoria, with the regular Friday night cast. Right, next article. What time is it? It's 1:45. Is there ever a time that the moon does not set or rise? Can you imagine a place on the Earth's surface where you never see the moon? Well, apparently there is. There are places where the moon does not appear above the horizon, or where the moon doesn't set, at least for a period of time. Let me see, where are we? Okay. Yes, there are places on Earth where the moon does not appear above the horizon. There are also places where the moon is circumpolar and doesn't set, at least for a period of time. To determine the locations where one would find the circumpolar moon, or see no moon at all, we only need to know the moon's declination. Declination measures a celestial object's angular distance relative to the celestial equator. The projection of Earth's equator onto the sky. One could regard declination as the celestial equivalent of latitude. The declination of an object directly on the celestial equator, such as the Sun during either equinox, equals 0. The declination of the north celestial pole is 90 degrees, and that of the south celestial pole is minus 90 degrees. A celestial object's declination determines its visibility region, where its visibility, not visible, and circumpolar. For instance, the Sun's declination on November 12th is about minus 18 degrees. Consequently, it will not be visible at any location north of 72 degrees north, which is equal to 90 minutes 18. Also, the Sun will be circumpolar at any location south of 72 degrees south. On the winter December solstice, the sun's declination is about minus 23.5. At this time, the sun will not be visible at any location north of 66.5 degrees, the Arctic Circle, and will remain circumpolar at any location south of 66.5, the Antarctic Circle. On the summer June solstice, when the sun's declination is 23.5, it will not be visible anywhere south of the Antarctic Circle and will be circumpolar anywhere north of the Arctic Circle. And they say here, note, we are conventionally neglecting atmospheric refraction effects and the fact that the sun is not merely a point in space. The same principle applies to the moon or any other celestial object. Its declination determines its visibility region. For instance, if the moon's declination is 10 degrees, it won't be visible anywhere south of 80 degrees south and will be circumpolar in any region north of 80 degrees north. If you know the moon's declination, you can subtract it from 90 to determine its region of circumpolarity and also where it won't be rise above the horizon. Whereas the sun is currently limited to the declination range between minus 23.5 and 23.5, the moon's range is between about 28.7 and minus 28.7. Therefore, it will always rise and set between the latitudes of 61.3 north and 61.3 south. Those of us at the mid-latitudes will always see the moon rise and set, just as we always see the sun rise and set each day. The variation is independent of phase. For instance, the summer solstice full moon has a much lower declination than the winter solstice full moon. So the full moon that occurs around the first day of summer will be circumpolar in many regions south of the Antarctic Circle, and the winter solstice full moon will be circumpolar in many regions north of the Arctic Circle. All that matters is the moon's declination. In summary, yes, there are places on Earth where the moon does not appear above the horizon at certain times of the year. We never see it. If you want to read that for yourself, you'll find that on astronomy.com website under Ask Astro. There's a tab at the top there that says Ask Astro. Usually they are short articles, which is why I always go for them. Anyway, there it is. VK3EKH you're listening to. And here's another quickie. Where's this picture? Bring this up. October 2, 400 in the year 480 BCE. October 2, 480 BCE, an eclipse causes a retreat. October 2, today in the history of astronomy, a solar eclipse darkens skies anonymously over the ancient Greece. An ancient solar eclipse changed the course of a military conflict when it cast a shadow on a battle over Corinth between the Spartans, commanded by Cleombrotus, and invading the Persians, led by Xerxes I, and Herodotus wrote that while Cleombrotus was offering sacrifice to know if they should march out against the Persians, the sun was suddenly darkened in the mid-sky, and as you might imagine, some 2,500 years ago, eclipses were not seen as good omens. And this one, which astronomers now think occurred October 2, 480 BCE, rattled the soldiers and caused a full retreat of the Spartan forces. How scary that must have been to them. Cleombrotus. Cleo, maybe it's Cleo. Cleobrotus. Struth. The Greeks. You're tuned to ASV Radio VK3EKH, and I think I can squeeze this last article in. Let me see. Can I? Maybe not. Maybe I could just do an intro on it. Courtesy of Science Alert, there is a picture here, a couple of pictures which I'll throw up. A signal hidden in a gamma ray burst could be a strange newborn first heartbeat. 1st of October 2025, sciencealert.com. And what you're seeing there is an artist's impression of a young magnetar. Astronomers may have recorded the violent birth of one of the weirdest objects our universe is capable of producing. In a bizarre gamma ray space exploration, in a bizarre gamma ray space explosion, whose light reached Earth in 2023, a team led by astronomer Ran Chao-chen of the Nanjing University in China has detected a signal they say is the birth cry of a newly formed magnetar, the most magnetically extreme objects that exist. This is the first time humanity has directly observed a periodic signal from a millisecond magnetar inside a gamma ray burst, Chen says. It is like hearing the first heartbeat of a newborn star. Gamma ray bursts are the most energetic explosions in the universe, and we know of at least two mechanisms that can produce them. Short duration gamma ray bursts lasting less than 2 seconds are spat out with the kilonova explosions that erupt from colliding neutron stars. And there's another little artist's impression here of that. Continuing on. Long duration bursts, on the other hand, are longer than 2 seconds, and they accompany the core collapse, supernova explosions at the birth of black holes. Well, more or less, a gamma ray burst detected on 7th of March 2023, named GRB 230307A, bucked this trend. At the time, it was the second brightest gamma ray burst ever detected and lasted 200 seconds, yet that way the light evolved in an aftermath of the explosion suggested a neutron star collision, not a core collapse supernova. Actually, it's not the only long-duration gamma ray burst linked to a neutron star merger. Another 50-second burst in 2021, named GRB 211211A, was linked to a kilonova, suggesting that there might be something else at play with these unusual explosions. When two neutron stars collide and merge into a single object, that single object's identity depends on the final mass. The upper mass limit of a neutron star is about 2.3 times the mass of our Sun, so an object heavier than that should become a black hole, they reckon. The data from both long-duration kilonovae suggests that the final object in both was a type of neutron star called a magnetar. And these objects pack incredibly powerful magnetic fields, roughly 1,000 times stronger than that of a typical neutron star. And these strange dead magnetic stars can get up to some weird shenanigans, but there's a lot that we don't know about them, including how and why they have such astonishing magnetic fields where our neutron stars do not. And I think I'll leave that there. It's only another couple of paragraphs, but anyway, that was just a very quick article on a hidden signal in a gamma ray burst that could be a strange newborn's first heartbeat, detected by a Chinese astronomer. Courtesy of sciencealert.com. All right, coming up to the hour, I'll skip that one there. Something about a metal detector has gone off. Perseverance rover finds a shiny new clue in the search for life on Mars. And I'll leave that till next week too. So let's just go straight to spaceweather.com. What's happening up in space? There is our current sun. That's what the sun looks like with the current placement of sunspots. The solar wind is currently at 762.4 kilometres a second at a density of 0.16 proton per cubic centimetre. The sunspot number is 161. The radio sun, the current radio flux, is 167 solar flux units. The current auroral glow over the South Pole is looking a bit like this right now. That one there. It was pretty strong yesterday. There was a lot of red in that yesterday. There would have been a possibility of seeing some aurora down the coastline, but I don't think so right now. The coronal hole is looking currently like this. A bit of a slash there at the bottom half of the sun, and the sunspot cycle is that at the moment. That's where we are on the sunspot cycle. The top being the sunspot cycle and the bottom being the radio solar cycle, radio flux, and they mirror each other pretty well. So that's where we are at the moment in our cycle. And finally, there is expected to be a minor storm today. A minor G1 class geomagnetic storm are likely to today as Earth continues its transit through a high-speed stream of solar wind. These are the last gasp of an occasionally strong 5-day geomagnetic storm that produced magnetic auroras around the Arctic Circle and about a dozen US states between September 28 and October the 2nd. Now, just a little bit of update on Comet 31 Atlas has reached Mars. So if we were out on Mars at the moment and look up, we would be seeing a close flyby of Comet Atlas 31, or 31/Atlas. There's a bit of a graphic here of this, not a video graphic, but this one here. It kind of illustrates a few things. Sorry about all the arms. Comet 31 Atlas has reached Mars. Interstellar Comet 31 Atlas is flying past Mars today, and Mars fleet is watching. We're about to get our best ever look at an interstellar comet, says physicist Marshall Eubanks from Space Initiatives, who is helping coordinate international spacecraft teams as they train their instruments on Atlas 31, or 31 Atlas. As many as 6 spacecraft could get a close-up view. NASA's MAVEN, Mars Reconnaissance, that's another word I trip over, reconnaissance orbiter, Mars Express, and ExoMars Trace Gas Orbiter, and one other, no, there's 2 others, there's something called a HOPE probe and a Taiwan 1, or Tianwen 1. Because 31 Atlas is now practically invisible from Earth as it swings behind the Sun, a blackout that will last until December, Martian spacecraft may provide the only jeez, I'm tired, I can see it. Provide the only high-quality spectra images of the comet as the brightest. The Starfleet, that's it, I'm cooked. I'll start that paragraph again. Because 31 Atlas is now practically invisible from Earth as it swings behind the Sun, in brackets, a blackout that will last until December, Martian spacecraft may provide the only high-quality spectra and images of the comet at its brightest. The fleet at Mars could deliver the definitive database or data set, writes Eubanks and colleagues, who authored a new study urging space agencies to seize this opportunity. When the comet passes Mars on October 3, it will be almost bright enough to see with human eyes, about magnitude plus 6.7, according to Eubanks. If only humans were able to see it, spacecraft will have to do all the work. The comet will be 0.195 AU, or 29 million kilometres from the red planet, giving the orbiting fleet a ringside seat. I'll leave the rest of that. All right, so stay tuned. By this time next week, we may have some images coming through from these various probes that are scanning for this Comet 31 Atlas. And I've been told that October 20, somewhere around October 20, will be apparently the best time to be able to see the comet in our skies here. But I'll keep tabs with that so we know exactly what's going on. Meanwhile, that's it. I'm tired. I'm out of here. Thank you for listening and putting up with my nonsense and bilge. And we'll be back here next Friday to do it all again at 10 o'clock on these various airs. And let me just check the email. I don't see any emails there. Let me just check the Discord channels. We have Andrew VK3KIS, Cassiopeia Nebs, Steve VK3SPX, and David, our resident Mount Burnett Observatory astronomer. G'day, David. Also watching the Discord channel. Okay, on that note, we shall conclude at 5 minutes past the hour. I shall open up 3541 for any stations wishing to check in, and we'll see how we go. This is VK3EKH, listening on 3541 kilohertz.
3 Delta X-ray. VK3SPX.
Feedback. That's because I've taken out the headphones. VK5 Whiskey Alpha, I think it was, at the beginning. You were jumped on top of by Greg. VK5 Whiskey Alpha, I think. It's Dallas. VK3DX, VK3SBX. Is there any other stations? All right. VK5 Whiskey Alpha, I think that's who called in. I recognised a VK5 at least. VK3EKH, go ahead.
Yeah, g'day Clint. Good show tonight. Thanks for that. Been paying you to call in, but never quite making the end. So, thanks again. Good evening. Catch you next time. VK5 Whiskey Alpha.
Yeah, thanks, Dallas. No worries at all. A good signal into Melbourne tonight. So thank you for the report. Greg, VK3 Delta X-ray, VK3EKH.
Yeah, good on you, Clint. VK3EKH, VK3 Delta X-ray. And good evening to VK5 Whiskey Alpha. And Steve, VK3SPX. I think there might have been someone else, but anyway. Interesting broadcast there, Clint. I'm waiting for that comet. That was going to give a look at it, mate. And looking forward to that part of it. You do sound a bit tired tonight, mate. You must have been busy. I won't ask you too many questions. I don't ask that many. I wonder how the observatory's going, and yeah, all good, mate. And good to hear you on tonight, and always a good show there, Clint. Well done. And back to you. And good evening to shortwave listeners. VK3EKH, VK3 Delta X-ray, Greg Inaudible.
Thanks, Greg. VK3 Delta X-ray, VK3EKH. Yes, today was an RDO for me.